So topic 4 is something I promised you in a previous worksheet that I would cover. So in the first worksheet for this chapter, we talked about simplifying rational expressions where you had opposite factors. And so what that means is like the example I think we looked at was we had x minus 2 over 2 minus x. And it's like you want to simplify because you see x's and you see 2's and you're like, these are almost exactly the same, but they're just not quite it. So we learned that we could factor a negative out of the denominator, okay? So we started by rewriting the denominator in standard form, and we could see that if we could factor out a -1 here, we could force the numerator and denominator to no longer be opposites. They'd be the same factor. So we would get something like x minus 2 over negative times x minus 2, and this simplified to -1. So that idea is going to come back, this idea where we have opposites. So what's going to happen is our denominators are now going to be opposites. So we're not simplifying. We don't need an opposite situation top to bottom. The denominators themselves are opposites. So we have to find a way to deal with that. So how do we deal with that? We have to find a way to get a common denominator, okay? And for something like this, where your denominators are opposites, the way you get the common denominator is you can just multiply one entire rational expression by -1 over -1. And that kind of takes care of it. So let's look at this and see what is happening. So if we look at example 4, it says find each sum or difference. So for part A, we have x squared over x squared minus 81 minus 9x over 81 minus x squared. I don't like 81 minus x squared. It's not in standard form. So I'm going to rewrite this. But when I do that, I'm going to write the second denominator in standard form. So it's negative x squared plus 81. And the directions up here, let me scroll back up. The directions up here say when one denominator is the opposite of the other, multiply one rational expression by -1 over -1 to obtain a common denominator. Okay, well, let's see what that looks like. So we're going to multiply the numerator and denominator by -1. Okay, and we'll see what happens. So that's going to give me x squared over x squared minus 81. We're not messing with the first rational expression. We're just multiplying the second rational expression by this weird form of 1, because -1 over -1 is just 1. And when we multiply something by 1, we don't change its value. But because we're making the numerator and denominator negative, it's going to make things work out with us for signs. So 9x times -1 is -9x. Negative x squared times -1 is positive x squared. 81 times -1 is negative 81. So things are looking pretty good. Our denominators are now the same. They're no longer opposites, but we have this weird sign thing happening. We have this going on, okay? So no problem. We know how to deal with that. We now have common denominators, okay? That's fine. We take our numerators and we put them over the common denominator. But you have to remember what happens when you subtract a negative. Well, when you subtract a negative, it just becomes addition. So this really just becomes x squared plus 9x all over x squared minus 81. Okay, so just be very careful when you multiply the top and bottom by that -1. You may have a weird thing happening with your signs. Okay, so this is one way to do this. I teach another way too, so we'll see how this one goes. Now we need to factor the numerator and the denominator. The numerator has a common factor of x, so I want to factor out an x. That leaves me with x plus 9. My denominator, hopefully you're really good at recognizing this. My denominator is the difference of squares, okay? So the square root of x squared is x. The square root of 81 is 9. So when you have the difference of squares, you take your square roots, you add them, and then you subtract them. And now you can see we definitely have a common factor. I have an x plus 9 in the numerator and an x plus 9 factor in the denominator. Well, the factors of x plus 9 divide to just become 1. So that tells me that my final answer is x over x minus 9. And that's it. So not too bad, hopefully, anyway. So there you have it. That is adding or subtracting, in this case, two expressions that have opposite denominators. So the method that the book shows you is to multiply the numerator and denominator by -1. I tend to do things slightly different, so I'll show you my method. Either method works. You'll get the same answer. Use the one you prefer, okay? So looking at part B, we have x squared plus 2x over x minus 7 plus x squared plus 14 over 7 minus x. I don't like the 7 minus x. It's not in standard form. So off to the side, I'm like, okay, I have 7 minus x. I would prefer that to be negative x plus 7 because that's in standard form. But remember, we don't like having that lead term be negative. So I would divide out a GCF of negative 1. Well, negative x divided by negative 1 is x. 7 divided by negative 1 is negative 7. So when I rewrite this, what I have is x squared plus 2x over x minus 7 plus x squared plus 14 over negative 1 times x minus 7. And then we have that weird sign thing happening right here. What happens when you add a negative? It just becomes subtraction. So this addition problem has now turned into a subtraction problem. So what I really have is x squared plus 2x minus x squared plus 14 all over my common denominator of x minus 7. Now, if you prefer the method that we learned over here, where you just multiply the numerator and denominator by negative 1, that is fine. Please do that, okay? If you like this method, please do this one. Do the one that you prefer, okay? Now, we need to distribute the negative through that second set of parentheses. So I get x squared plus 2x minus x squared minus 14 all over x minus 7. And then we want to combine like terms. So when I combine like terms, let's see, I have an x squared minus an x squared. Well, x squared minus x squared, we would typically say it cancels, but remember, it doesn't just disappear. It cancels to become 0. X squared minus x squared is 0. So I get 0 plus 2x minus 14. So that's just going to be 2x minus 14 over x minus 7. Well, 2x minus 14 has a GCF of 2, so I want to factor out the 2. So 2x divided by 2 is x, negative 14 divided by 2 is negative 7. And notice we have a common factor of x minus 7, top and bottom. So x minus 7 divided by itself is just 1. So this simplifies to be 2 over 1, or really just 2. So I've kind of shown you two different ways to deal with adding or subtracting rational expressions with opposite denominators. Again, if you prefer the idea of just multiplying the numerator and denominator of the opposite denominator, if you prefer multiplying numerator and denominator by negative 1 and then going with that, knock yourself out. Perfect method. If that's one you like, go with it. If you like just kind of dealing with your denominator and then switching your operation like we did in part B, perfect. Go with that. Both methods are great. Both methods always work. It just depends on which one you prefer. Okay, so in the next worksheet, we're going to start looking at what do you do when the denominators are not the same with addition and subtraction.